Absolutely. So we break something down. And I'm going to say break a material down because it's not always about rocks. So breaking, and if you were not here yesterday, this is a good thing for you to put in your notes. Breaking down a material into smaller parts. That's weathering. We break something down into smaller parts. That gets us started. Now, there's two ways we can do that. Billy, give me one way that we can weather something. Let's go ahead and start there. So let's go ahead and start with chemical weathering. Can someone please tell me what is chemical weathering? If I'm going to chemically weather Alex. Or Peyton. Go ahead, Asa.
You change the composition of it?
Yeah, I'm going to change the composition. So chemical weathering is changing the material at the molecular level. Okay, and so you have made new substances. The reason I say substance is with an S is because in order to chemically change something, you have to add something new to your material. And I want to go ahead and show you that real briefly. If you remember when we did our chalk, okay, we had the chalk and we crushed it up and we put it in something and then we poured what over top of it?
Acid.
Acid. We poured an acid over it. So we added a new material in order to change this one. And I want to show you what that means. So if you can look up here, let's imagine that this is the material, okay? And it's the chemical bonding of all the little atoms that come together to make a molecule. I then put this in here. That's my receptacle. Then I'm going to add this new product to it, this new material, which is a different kind of molecule made up of all different kind of atoms, and I put that in there, and I give it a shake. Shake, 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 shake. What happens in there is this. This atom, or this molecule, is breaking apart. This molecule is breaking apart into the different atoms, and then what happens is they end up coming back together in a new and different way. And so what you do then is you get new substances made out of all of that breaking apart and then coming back together. So then what we're left with is like maybe a new substance, and then you remember the bubbles we saw?
Yeah.
Maybe this is gas that then floats away. Okay? So then that's what happens. You take two things, you put them together, and then you get different materials afterwards. You're literally changing the material at the molecular level and you get a new substance. Like rusting. Has anybody ever had anything that you left outside and it rusts? That's iron rusting or mixing with oxygen, and so then what you get is like an iron oxide. All right, so that's one way. What's the other way that we can weather something? Yep, in the back. Physical weathering. So we can go ahead and have physical weathering. Can someone please, now that you have an idea of chemical weathering, return to your pair share partner and talk about what physical weathering is. You've got 10-second countdown, ready, set, go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and we are done. All right, somebody raise your hand and tell me, please, what would be physical weathering? Will in front.
It is like changing the shape of it without changing the molecular.
Okay, so we're not changing the molecular level. It's like when we physically touch it, but I don't want to use the word physical there, so it's like, how about this? This is a gross pepper. Changing a material's shape or size could say handling it. Physical pressure, physical touch. Yeah, changing material shape or size by touch. You handle it. You step on a rock and it cracks. It's still the rock, it's just that rock now broken into little pieces. Asa, you want to add something or change it?
Wouldn't it be shape and size?
What did I say? Shape or size? Shape/size. How about that? Yeah, I guess because if you change the shape of something. Yes, darling.
Isn't physical basically like you changing the outside and not the inside?
You could, if we're looking at like molecular inside, yes. But I could crack a rock right in half and someone might say that that's the inside.
Like a geode.
Like a geode. Yeah, it allows us to see what's inside. Yeah. So physical weathering is just like me when you took that chalk and you were crushing it. You were crushing the chalk. That was the physical weathering. You were literally physically touching it and then you were changing its shape or size. Chemical weathering was when we started pouring acid over it and we saw those bubbles that were forming. Those bubbles mean that we created a new substance called gas. And so that gas was then floating away. How's that feel? Get us kind of like the juices flowing, like, oh yeah, I kind of remember what we did yesterday. Fabulous. So then that's what we're going to be doing today is we're going to go back to our changing chalk because we have to go ahead and do the last part of it, get that set up so that we can start collecting data. I love your glasses. So what we're going to do is we're going to have you go back to your groups you were in yesterday, and here's what I need. At each table, there is one of these on each table. Actually, there's two. I have one for this hour, and then I have one for next hour. So please only use one of them. I need somebody to please walk around and give every group a little piece of tape, and there's a marker at each table. Somebody at your table put class period 3 and then your table number somewhere on this, because we're going to go ahead and have you open up the little plastic canisters at your table, grab a rock chip, and we're going to go ahead and see if we can physically change a chip of marble. So can everybody please get this piece of paper out, changing chalk. We're going to go ahead and go back to that, and we're going to draw up a little bit of a procedure as far as what we're going to do. And again, if you weren't here yesterday, let me get that for you. Is that where you were going yesterday? Because in your ankle. Sorry, man. Could you hand that back to yourself?
Yep.
Does anybody else need a copy from yesterday? You need a copy? I think you got one though, didn't you? Did you can't find it? Lexi, did you get one of these or did I hand it to you? You got one? Could you hand that all the way back to Justin, please? Sorry, I expect you to like reach that way. Everybody else good? All right. Let's look at what it was that we did yesterday. So yesterday we said, did we really change the chalk and then we put acid on it? And then we talked about this. We talked about how physical change is changing the shape or size of the matter, but not its identity. We said something like that. And then chemical change is when we are changing matter at its molecular level, and it changes the identity. It's no longer like H2O, right? The H and the 2, they've separated out, and then they've created something else. And we know that a chemical change has happened when we see bubbles, when we see a color change, or when heat is transferred in some way. Like an ice pack or a heat pack. If you have those and you crack those in, you know what I'm talking about when I say that? Okay. So then we said, but this is just chalk. Can we really change a rock? And so I'm giving everybody at your tables a little marble chip. Does anybody remember what kind of rock marble is?
Metamorphic.
It is metamorphic. What did it start out as?
Line.
Limestone, sedimentary limestone. And through what process did it change into metamorphic rock?
Heat and pressure.
Heat and pressure, darn right. All right. So now what we're going to do is we're going to see if we can change this rock, and I mean really change it. So if we really want to change it, here's how we're going to do it. Step 1, because we want to mass it before and after. So everybody, let's write down the procedure. Number 1, you are going to mass the rock. I'm going to say chip. And a rock chip is just like a small piece of the rock that has been chipped off. So number 1, we're going to mass the rock chip. Number 2, place chip into glass beaker. The beakers are these small things that look like this. This is a beaker. Okay, it's just a small one. Number 3, what should we do if we want to actually change this rock?
Acid.
Right. So we're going to pour acid over rock. And then number 4, let sit overnight. And I'll stop so you can write that down. So then what I saw, we're going to write day 1. Oh yeah, that's nice. Day 1 observations. Once we pour that acid over that rock, I want you to look at it to see if you can see any observations. Then what we'll do is we'll come back day 2 and we'll look at it again and write down new observations. But what we're going to do is we're going to mass that rock. So please make sure that you have your scales turned on to grams, and then mass that rock chip, then place it in, and I'll come around with some acid. I need somebody to please walk this around and give every group a little piece of tape. Who would like to do that? Right. If you could please just give every group a little piece of tape so that they can write that on there. Please go to your lab tables and go ahead and have somebody open that up, open up that little plastic jar and mass out. Get your mass in grams, okay? You're going to be at the same tables you were for your rock cycle starburst. For those of you that weren't here yesterday. And I am going to walk around with my video, but I will make sure that I don't put anybody's face on the video.
Same group as what?
As our rock cycle starburst. Don't forget your paper, bud. Oh, don't say that. Do you remember where you were? Do you remember where you were for when we did starburst, where we cut up the starburst and we melted them? No. Yeah, I think you were with Nikayla. Come on, go over there. Strong, independent women. All right, so if you could, yep, and then open up the little jar, and you decide, you guys, which one you want.
Can we just take one?
Yep, choose one. Decide which one of the rock chips that you want, and then you're going to go ahead and measure that. And then, yep, on grams, you put that on there. All right, I'm going to go ahead and just see this so that for those people that are at home, this is what we started with. All right, and you're going to write it down there. Nice job. All right, so once you find out what it is, all you're going to do is, yep, perfect. Write it down there. Wonderful. All right. Now what I'm going to do is I'm going to come around with some acid. Does everybody have it labeled? Make sure you label your glass. Alex, sweetie, we're just measuring only the rock and not the rock and the glass.
Only one rock?
Just one rock. Just one rock. The rocks are there for all of my classes. So just one rock, put it on the, you should have a marker, sweetie.
What'd you rate on this?
Okay, I'm gonna get you a marker. I'm gonna throw something at or to you, but I'm not trying to throw something at you. All right. So put your class period and name, not name, table number on each. And now I'm gonna go ahead. Come on, honey.
It's a bone. Can I write it down?
That's fine.
It's
Okay, did you pick one?
Yes, we're there.
Oh, okay, I'm sorry. And we masked it out?
Yeah, do we do it like when it's in the beaker?
No, just the rock.
Okay, yeah, we did that.
So you're good? Okay, so now what I'm gonna do, for those of you that are at home, now I'm gonna go ahead and cover it with acetic acid solution. And we're gonna have this group, I can't find it. We're gonna have this group make some observations. All right, so now y'all, look at it and write down any day one observations that you can see. Migraine.
Where do we put the paper?
Just anywhere on your glass, so that you can identify it as yours.
Put the mask with
Yeah, you're supposed to put the mass here.
the beaker.
No, just the rock.
Yeah.
Mass just with the rock.
Okay, now put the rock in.
Did you already mass it?
Yeah.
Okay. All right, I'm gonna come around and now make some observations of look really closely at the edges of your rock. Could you take that off for me? So 0.7 was without it, right? Without the glass beaker, it's just the rock.
I'd say it has rough edges.
Okay, so now go ahead and look at it really closely. Put it in the middle. Look at it real close. And let's see any observations on day one. You should start to see some observations right away.
Yep.
Could you hold that still? All right, so I'm going to walk around, and you should start to see observations immediately. You seeing it?
It's just bubbling.
Well, what do you mean just? That's the magic.
No, I'm being.
Oh, look, I can see them.
Can I put my finger?
That Michaela's wanting her paper back. So
That was dramatic.
excuse me. Yes, it does. There we go. I can see. Let's be nice. You can definitely see bubbles, and so if there's bubbles, we know what's happening.
It's chemically changing.
Boom! Chemical reaction.
Yeah, first hour.
All right. So write down what you are seeing. Oh, I did it. I'm sorry. Forgot one group. Sorry, I'll be right back. Make some observations. All right. So now what we're going to do, listen to my face. Please take your beaker, now that you've made some observations. If you'll notice, right there underneath Tony Stark, we've got a line of beakers. Could you make another line in front of those so that we know the ones furthest away are going to be first hour, you are going to be third hour. And then when you're done, could you please come back to your seats? We're going to take a little bit of notes. We're going to come check on this tomorrow and make some observations for day 2. Right now, though, let's go ahead and put them along the wall. Tomorrow we will come back and mass them again to see if any change in mass has happened. I am anticipating we should have a change in mass. All right. So day 1, you told me that you saw bubbling, so I'm going to write that down. No. And I went and looked at, I think it was Billy's group. Billy, can you tell me what was the mass that we started with? 1.0 grams. That's just what I'm going to do for my example. And then tomorrow I'll come back around and add to that. All right, nice. Who had their hand up? Asa, question.
I didn't have a question. I was gonna say, I wrote down gases are being released.
Gases are being released. So bubbles meaning gases are being released. Absolutely. I appreciate that. Very specific. All right, sweeties. Now what we're going to do is we're going to go to take some notes so that you feel like you are going to be a little bit more prepared for what we are doing on Thursday, which is your quiz. And so if you could please get this sheet of paper out. You picked it up on the way in. W.E.D stands for what? Weathering,
Erosion and deposition.
deposition. So that's what we are going to be doing today. I'm going to turn the front lights off.
What about your TOC?
Does everybody have a writing utensil? All right, so we're always going to start with an essential question. I'm going to move this like this. Hopefully you can do a little better. I am really sorry about how gross my handwriting is, but I am working on it. So the first thing that we are going to do is write down the question that we're going to start with, and that is, come on, pen. How do weathering, erosion, and deposition work together to shape the earth? Weathering, erosion, and deposition. You can just say work together if you want.
It's at the bottom in the circle.
What's the matter?
The questions at the
Yep, oh, it's at the bottom, yep, because that brings you back again, to shape earth. This gets us kind of like a focus though, when we start as far as what are we doing. Can I just say, do you guys know what PTO is? Like PSTO? So it's a parent-teacher organization, and today they brought us goodies like donuts. Isn't that nice? I thought that was really a nice way. I mean, then I made the coffee, but still sweet. I'm sorry, I don't have enough donuts for everybody, but would you like a bite of my donut, Hassan? Do you want a bite of my donut? Okay.
Well, I think I was supposed to bring something.
So what does the W stand for?
Weathering.
Let's go ahead and write that down.
I didn't bring it. It's in my cover. I was supposed to bring water.
Weathering. And so does anybody want to remind me of what weathering is? William in the back, what's weathering? Yeah, and so it's breaking stuff apart. So we're going to say, break down the Earth's crust into sediments. We're going to focus as far as like weathering in the rock cycle. Break down Earth's crust into sediments. And there were 2 small articles that you had to read one night for homework. And we talked about like chemical weathering, physical weathering, and they also mentioned biological weathering. Although I don't have biological weathering here. Biological weathering is kind of like if a worm goes through the soil. If a worm's going through the soil, it's weathering, putting holes in the soil. If you step on like, if you're hiking and you're stepping on a trail, you're weathering the ground. So let's go ahead and look at first one, which is physical. And a lot of you, I would say every one of you have had this first kind of physical weathering happen if you ever have scraped your knee. This kind of weathering is called abrasion. Has anyone ever fallen and scraped a knee or an elbow? My God, you have just weathered your body, right? Because abrasion means to wear down by rubbing. So you have left a little part of yourself on the pavement, but you've not changed that skin, you've just lost that skin and left it on the pavement. Ew, right? You've reduced your mass just a little bit. Will, get your hat off the desk, man. All right, now we can have weathering by abrasion, and that can be by the wind. The wind, if anybody has ever been at Coralville Reservoir at the beach and it's a windy day, does it hurt?
No.
What? The wind picks up the little sand and what's it do to your body?
It's like sandpaper.
Yeah, it's like sandpaper, it hurts. It like blows and like tink, 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 it hurts you. Water can also go ahead and, okay. Water can also abrase things. If anybody was ever a rock hound when you were a kid and you had the ability to get one of those tumblers, rock tumblers, I wasn't, but I always wanted one. And so it makes the round, smooth edges of the rocks, and that's because you're just kind of like tumbling it. And then also glaciers. Does anybody know what a glacier is?
Frozen lake, frozen rivers.
Yeah, and so we're going to go ahead and put here that a glacier is a river of ice. And they're really good at breaking down material, almost like grinding. And so if anybody took their chalk and on the piece of paper that I gave you yesterday, that orange card, and you just kind of like rubbed the chalk on the piece of paper, you were weathering through abrasion. All right, let me move down a little bit. Another way that we can physically weather the crust is with temperature change. I'm just going to say temp change. And the way we do that is really an amazing property of water, and we'll talk more about that when we start talking about water. But when you freeze water, what happens to its size? Yeah, and when you thaw it, then it gets smaller. Yes, and so that is called contract and expand. So I'm going to say actually expand and contract. Expand/contract. Now, another way that we say this is like freeze thaw. So when you freeze it, it expands, and when you contract it, when you thaw it, it contracts back down again. And that constant kind of like expanding and then contracting and expanding and contracting weakens rocks, and then they crack and break. It's easy to break them. All right. And then we can also have what's called ice wedging, which is connected to this process. Ice wedging is I'm going to draw a really quick picture for that. So if you had a rock and you have a crack in the rock, and then water gets into that crack, and then overnight it freezes, then what can happen is that water expands a little bit, and it makes that crack bigger. Then the next morning it thaws, right? But you've already cracked it a little bit deeper, and so then the next day, that water, that next night, gets further down in that crack, and it makes it a little bit deeper, and over time, this ice wedging is because it's a little wedge of ice that is in there. And so it just kind of like wedges it and makes it bigger and bigger and bigger. Physical weathering, you've got direct contact with something. All right, now, dang it. Abrasion is slow weathering, unless of course you're a little kid and you hurt yourself. Temperature change is what's known as slow weathering, but the next thing we're going to talk about is a little bit faster weathering. So I'm going to write fast down here. And in your readings, this would have been called like accelerated weathering. So one of those examples would be like an earthquake. Oh my gosh, can we pause for a minute and talk about the terrible things that are happening in Turkey right now? Has anybody been seeing the news as far as I know, do you have family? But have they been directly affected?
No.
God, thank God. So there's been, has anybody seen, it's like a 7-point-something earthquake. Have you seen it? And it's like entire cities have just been razed, right? Like very few buildings. Are there people that don't know what I'm talking about?
10.
It was a what? It was a 10.8 earthquake? Let me see if I can bring up pictures really quick. I think the highest we can go is 10, bud.
Yeah.
All right, so let's go ahead and look at Turkey. Oh, first thing that come up. Turkey, Syria earthquake. It has just been, like at first when I was watching it, it was like, oh, 1,700 people, and now they're up to 28,000 people dead, and nobody should be able to be pulled from the rubble anymore. But thank God that some people still are being pulled from the rubble, like at this point. This is the epicenter where it was happening, and we're talking like it's crazy. Like this was an apartment building. It's crazy how much of the city is just destroyed. We need to see a video. We need to see a quick video.
You can just go to videos.
Oh, thanks, man. Oh, nothing like that big. Here, let's just look really quick, CBS News. It's like nothing I've ever seen before, and I can't believe that these poor people are experiencing this. And I don't know why we have no sound. Why is this happening?
Because it's
Oh.
muted.
Go on to the video.
Look at that.
I don't want to see this crap. I just want to see the stupid earthquake. Do we have to watch this whole thing?
7.8 magnitude.
I feel like I've been like,
Videos.
okay, here we go. So there was the initial earthquake. Sorry that we can't hear it, but it's fine. Aftershock then. And then look at this poor, I mean, it's just like, just everything has just been totally affected. It's like crazy. I mean, imagine like all of the buildings in Iowa City just coming down. Like, where do you stay? There is no place to go.
Dang.
I mean, little babies have been, saved like 5 days after. And then, like, what do you have? You have nothing. These poor people. The amount of people that they have lost in their lives. I just wish that they did an aerial view so that you can kind of see, like, the actual... Yeah, it's just absolutely terrible. And now they've got, of course, dogs trying to find any kind of signs of people that still could possibly, God bless, still possibly be alive. Can we see, like, do you think if I say, like, aerial view?
Yeah.
I don't know how to spell that. Their aerial footage. Oh yeah, check this out. Look at the crack.
Video play after ads.
This one is half as,
You're good. You had it.
Poop bags.
wow.
So look at the crack. Do you see the crack all the way running through? So when I look at this and I don't, I was gonna say shear force. Yeah, it looks like a transform kind of situation. And roads were totally destroyed, so of course you can't get in there to like help people. It's just amazing the crack that kind of ran through. Well, look, they had to make like bypasses and stuff. It must be fast forwarded a little bit. Eh?
Yeah. Jeez.
Just amazing. I mean, such a strong earthquake. These poor people, devastated. Yeah, anyway, terrible. Yeah, scale of earthquake. Sure, we'll watch that for one more minute.
With the same ad.
Poop bags. Yeah, it's just been like, it's all I've been watching at home at night is this. I just keep looking at my husband with tears in my eyes thinking we are so blessed. Look at this. I mean, it's just like buildings just crumbled. Like somebody physically weathered that. Well, they were, I guess, physically weathered. Just, I mean, just gone, right? Yeah, gone, gone, gone. I mean, this was a city.
Look at all the cars.
Just terrible. And then, of course, this is a stadium, so where do you try to make place for you to, I mean, that was an apartment building. Like, and people are still searching, hoping that, people are like alive in there. I mean, and people are like out in the street, with burn barrels, just trying to stay warm, and of course, holding vigil for their loved ones. I mean, oh my God. We are very lucky. We are very lucky. So my thoughts are for your family and the people of that area. Just terrible. Okay. So earthquake would be more like a fast kind of weathering, and we call this mass wasting because a whole lot of mass at once gets moved or torn apart. So this is called mass wasting. And landslides, would be an example of that. Terrible, just terrible. Let's see if we can get through chemical weathering before the bell rings. How much time do we have? Yep. 8 minutes, we can get through that. Okay, the first one is, I think we talked about it earlier, if you've ever left something outside and it has rusted. It's called oxidation.
Copper oxidation.
Which I know that there's this product called OxyClean. I don't understand how it works. But this is where you have rusting. I'm just going to give an example of rusting iron with oxygen. So again, remember when we had to add something to it. In this case, we are adding oxygen to the iron. Oxygen. You can also have oxidation with copper. When we oxidize copper, what color does it turn?
Green.
Green, like the Statue of Liberty. It's a green giant woman, right? But it used to be copper. It's just been oxidized. This one you might not be familiar with, but I want you to look at the prefix of this word. It's called hydrolysis.
Has to do with the hydrosphere.
Ah, hydrosphere. How do you know it has to do with the hydrosphere?
Because it has hydro in the
Hydro in it. And so something's going on with water. In this case, we are breaking things down with the use of water. And to lyse something, this lys at the back, it means to break apart. And so what we're doing in hydrolysis is we are using H2O, which means what? Water, to chemically change. So I'm going to say chem as an abbreviation, period, change. Now, you might not have ever seen this, but does anybody know of pink granite?
Yes.
Yeah.
Okay, so the pink in there is pink feldspar. And pink feldspar are the little tiny pink crystals, and through water, those can change into chalk. Chalk, as we notice, is very brittle. You can take chalk and just break it with your fingers. You can't do that with granite. Feldspar is very hard. So we can turn with water and dissolve that feldspar, that pink crystal, into something softer like, oh, I'm sorry, it should say clay, not chalk. Should say clay, not chalk. I'm so sorry. Sorry, it should be clay, like a real soft sort of like clay.
What does feldspar
Sorry
look
about
like?
that. Say again?
What does feldspar look like?
Do you really want to see? To the rocks! So feldspar looks like this. It's pink. And in a piece of granite, you know how there's little pink crystals in it? You get little pink pieces of feldspar. And so with the right kind of weathering, this will degrade and turn into something really soft like clay that I can just do this and it will end up on my finger, which will be easier to break. But right now, it's super hard and it won't do that. We should totally get the rock box out and we can look at all the different rocks.
Have you collected?
I like rocks. Okay, do I have time for carbonation?
Yeah.
Okay, what do you know about carbonation from your life?
It's in drinks.
It is in drinks. What is it? How do they make it? Bubbles? Yep, it creates bubbles.
They put a lot of carbon dioxide.
Carbon dioxide. And so think about that. Carbonation, carbon dioxide. And so in this case, we have carbon mixing with water. So carbon mixes with H2O, and this equals a weak acid. Yes, you are. You are literally like, if you drink enough soda pop, it like takes the enamel off of your teeth, right? If you want to really clean car parts, like engine parts, you can take them apart and soak them in Coca-Cola, and they clean the engine parts really, really well. I mean, don't pour Coca-Cola over your engine, but you know, like to clean the gross stuff off. So carbon mixes with water, and it creates a weak acid, and this dissolves rocks. Who has been to Makokata Caves?
I have.
This is carbonation. It dissolves rocks that are made, that are like limestone. Carbonation, so imagine the carbon dioxide in the air, and it mixes with the rain, and it creates a weak acid, and then that weak acid goes through cracks in limestone, it dissolves the limestone over time, and it makes those cracks wider and bigger, and those are caves eventually that you can walk through. If you have never been to Makokata Caves, go this summer. It's a great place, it's free, you can wander around the caves, but I would recommend bringing clothes to change into, and a garbage bag to put your dirty clothes in so that you don't have to be gross in the car.
Oh, come on.
It's the best. And then when you're deep in the caves, shut the light off just for a second, and it is so dark, and then turn it back on. And if you see bats in the cave, don't touch them, because, you know, you have to, well, you're bad for them, right? You don't want to make them sick. Tomorrow we will go with erosion and deposition. Awesome job today, and we will check our rocks to see what has been dissolved. Could you, Michaela, would you shut the video off, please?